Hello everyone. We're going to be taking a look at writing exponential function word problems for a brief period. I know that we kind of ended last class on it, but we're going to take a slight look back on that as well as adjust our thinking slightly. And then we've got some other notes to do as well. Unfortunately, this does need to be multiple videos. I'm just finding that the application that I use to upload videos doesn't really work if I switch out to different notabilities, which is required for this lesson. So there are going to be a couple of videos that we're going to be watching today, but hopefully they can all be a little bit shorter. So first exponential review of what we did last class is we learned exponential situations can be written in the form a times b to the x power, and a is our starting value, b is our growth rate or common ratio, and if b is in between 0 and 1, then that situation is going to be decaying over time or shrinking, and if b is greater than 1, then that actually is exponential growth. So for our first problem situation, and I'm going to do 3 of these together just to kind of get the gist or the additional learning here that's going to come around talking about these percentages, and then you're going to complete the rest, and that'll kind of be your first section of this lesson, followed by some other videos. So here, initial population of turtles. So I'm going to start this with population of turtles, population over time is our function. So initial population of 750, and then we are tripling each year. So this is 3 to the t power, or where t is basically time in years. So what will the population be after 5 years? And so this is pretty much how clean I'd want it to look like, where you've chosen kind of a function with appropriate variables here. Makes things just a little bit clearer, and then I'm going to plug 5 into there. So 750 times 3 to the 5th power, we end up with 182,250 turtles. So lots of turtles kind of coming into play, and if we're tripling year after year, that's probably to be expected. So we have this many turtles after 5 years. For our next 2 problems, we're going to be dealing with how we basically use a percentage in order to get to our common ratio. So here we have the population of Baconburg starts off at 20,000 and grows by 13% each year. So we have the population of a town, but t is just time in this case, is 20,000 times. So if we're growing by 13% each year, that means that next year I would expect 113% of the population. So this, converted to a decimal, is what we're going to use as our common ratio. So we're going to do 1.13. That's 113% converted. Sometimes people just slide those to the left in order to get your decimal, but that is our common ratio. Population after 10 years then. So that's going to be, 20,000 times 1.13 raised to the 10th power, getting a population of 67,891.34, is kind of what our model is predicting, at least. And again, the kicker that we're going to learn from these 2 kind of components here is if I'm growing by a certain percentage, I'm going to add that to 100, because obviously my ratio needs to be above 1 in order to grow. And it's easy to think, normally I just say, okay, that's 113% of the population next year. Convert that to a ratio of 1.13. In this particular situation, the house problem, a house is purchased for $150,000 in 2002. The value of the house depreciates at a rate of 7%. So this is going down by 7%. And the most common error here would be to use like 0.07 as your ratio. But if something's decreasing at a rate of 7%, that actually means that it's retaining 93% of its value the next year. So that would be written, our common ratio here would be 0.93. So in this case, I'm doing 100 minus that rate of 7% because I'm going down. So the value of the house over time is 150,000. I want that to kind of be a comma, times 0.93 raised to the t power. So the value in 2013, so the difference between these is going to be 11 years. And my unit is in years, so I'm going to find V of 11. 150,000 times 0.93 raised to the 11th power is going to give me my answer. So let's type that into our calculator. 150,000. You end up getting, oh, nope, sorry. Incorrect number in my calculator. Scratch that. 67,515.53, and this was dollars. So that is going to be the value of our house. So your first kind of component to this lesson is to practice just using these percentages and increase or decrease in order to come up with our common ratio and answer the questions as they're being asked. That's the first component, but then there's going to be some other videos here for you as well.